Hi, in this video we will do some examples for the rules of differentiation, in particular the sum, difference, power, constant multiple, and the constant rule. Let's see what we have here. First example, we are supposed to find the derivative, so let us start. F prime of x is the derivative of this polynomial. To differentiate a polynomial, you don't need anything but some differences and power rule and constant multiple. Basically, I need all of them. So what you do, these are sum or difference of functions. We can first differentiate each one and then add them. That's what sum and difference rules say. And as a result, we have derivative of first one, x to the power 4. This is power rule. This is 4x to the power 4 minus 1 minus. That 5 comes out, and we have the derivative of just x squared. Let me just leave it like that for now. And then derivative of 3, derivative of every constant. The constant rule says it is 0. 4x to the power 3 minus 5. Derivative of x squared, power rule, nx to the power n minus 1. 2x to the power 2 minus 1. And then plus 1. I don't need that plus 1. Well, then let's simplify this thing like minus 10x. That's what we have. How about the second one? Okay, the second one goes the same way. So we have to find g prime of x, which is, well, derivative of different terms. I can find derivative of each one. I'm trying to use different notations such that you have seen, you see different notations for derivatives. So these are derivatives of each summand. And then we go from there. X to the power 3. The derivative of x to the power 3 is, use the power rule, 3x to the power 3 minus 1 minus. 4 comes out, and we have to find the derivative of x plus. What is 5 over third root of x? We can write this third root of x. Let me write it here. This is x to the power 1/3. If it is in the denominator, I can bring it up and write it in the numerator. So it means that this guy here is 5x to the power negative 1/3. And since we are trying to find the derivative of that, 5 comes out as the constant multiple rule. And we have to find derivative of this one. And then we have derivative of 1/x. 3x squared is this piece minus derivative of x. You can see it as x to the power 1 and apply power rule. You see that derivative of x is 1 plus 5 x to the power negative 1/3. So negative 1/3 x to the power negative 1/3 minus 1 plus derivative of 1/x. You use power rule, or, well, I told you try to memorize that. 1/x, the derivative of 1/x is negative 1/x squared. This now gives us almost everything we want here. This is negative 5/3 x to the power negative 4/3 minus 1/x squared. Well, you can do a little bit more. These are not related to differentiation. This is just general simplification things that at this stage you don't need to be worried about. Just try to understand the differentiation rules. Let's do this other one. Well, first thing that you see here, you say, okay, this guy is quotient of two functions. I don't know how to do with the derivative of quotient. You're right. So far we don't know. We will learn later. It's called quotient rule. But this function, you can turn it into sums of good functions. So what I can do here is that, well, separate the denominator for each one. And then you see here, this is x to the power 2, the first one. And then you have, in the denominator, you have x to the power 1 over 2. X to the power 2 divided by x to the power 1 over 2, it will be x to the power 2 minus half, plus 3. X to the power 1 minus half, minus 5, x to the power negative half. I'm not doing differentiation so far. I'm just rewriting function hx as 2 minus 3 over 2 plus 3x to the power 1 over 2 minus 5x to the power negative 1 over 2. So this is sums of constant multiples of powers. That is what I like, because I know how to differentiate those kind of objects. First, apply the sum rule. So we have to find each one of the derivative of each one and then add or subtract. And then we have power rule and constant multiple. Let me apply the constant multiple rule first. This 3 comes out and we have to find the derivative of this piece. 5 comes out and we have to find the derivative of this one. And x to the power 3 over 2. X to the power n is 3 over 2n times x to the power 1 less plus 3. This is 1 over 2 times x to the power 1 over 2 minus 1 minus 5. Negative 1 over 2 x to the power negative 1 over 2 minus 1. This is 3 over 2 x to the power half plus 3 over 2. I'm multiplying the multiples, the constant multiples. This will be this guy. And the last one is 5 over 2 x to the power 3 over negative 3 over. So that gives us the derivatives we were looking for. Okay. So that was the first example. The second example is about the derivatives, the value of the derivative. Something is missing here. We are looking for g prime at 0, not g at 0. Well, it means what? It means that we have to first differentiate. So we have to find what is g prime of x. In this case, again, applying sum rule, we have this. Then constant multiple gives us this one. Then the power rule. Apply the power rule. This first one will give us 5x to the power 1 less plus 4. Derivative of x, you just know it's 1. You can apply the power rule for x to the power 1. Plus 0, derivative of a constant is 0. What did we find? Is g prime is equal to negative 15x to the power 4 plus 4. Now we are trying to find g prime at 0. That means that plug in. So to find the value of derivative at a point, you have to differentiate first, then plug in. How about this other one? Yes, so we have f of x. We want to find derivative of that. First thing you notice is here that, well, this guy is product of two things. Again, I don't know how to find the derivative of two things. Product of two things. That's product rule, and we will learn it later. But for this example, you can first multiply this x, distribute x in on this bracket. So this will be x squared times x cube is x5 minus x cube plus x to the power 2. I didn't do differentiation. This is just an algebraic thing. I just multiplied. And then Then what is f prime? Now that you do this is a polynomial, so this is sums or differences of constant multiples of powers. So we can apply first sum or power or difference rule. And then to find derivative of each one, we can use power rule. 5x to the power 5 minus 1. 3x to the power 3 minus 1. 2 times x to the power 2 minus 1. Then what we found, g prime is 5x to the power 4 minus 3x to the power 2 plus 2x. Now plug in the value. Oops, not g. Why does that work? Okay, now it works. F prime at 1, just plug in 1 there. So 1 squared plus 2 times 1. This gives us 5 minus 3 plus 2. Which when you add up, you get 4. This is nice. So that was the second example. The third example is interesting one. We are trying to find an equation for the tangent line at a point. Tangent line to the graph of function at a point x equal to 1. So remember that to find an equation for any line, you need first a slope, which in the case of the tangent line, it is the derivative of function at, well, here x equal to 1. And we need a point. In the case of the tangent line, the x1 is going to be the value of x, and the second component is f at 1. So f at 1 is 1 cubed plus 4 times 1 squared minus 5, 1 plus 1. So this gives us just 1. And the point, or a point that the line passes through is 1, 1. And we have the derivative of function at 1. And then we will go ahead and find. Well, means what? Means at this stage we need to find the derivative of this function. This function is a polynomial, so derivative will be sums of the derivatives of the terms and then add them or subtract the way it was the original form. So this will be 3x squared plus 4 times derivative of x squared, which is 2 minus 5 times derivative of x is 1 plus 0. And what does this computation show us is that this is 3x squared plus 8x minus 5. Now we have to plug in 1 for x. It is 3, 1 squared plus 8 times 1 minus 5. And you subtract, you get, well, 3 plus 8 is 11 minus 5, this is 6. The slope is, now we found it is 6, and then the equation y minus y1 equals to m times x minus x1. This gives us y minus 1, this is y1, this is x1, equals to 6 times x minus 1, and that gives us x, 6x minus 6 plus 1, and y is 6x minus 5. Well, we did some examples. I hope that these ones were enough for you to review the section 2.2 and the rules covered in that section.